This topic in ALEKS is called the area involving rectangles and triangles, and that's exactly what we're going to do. Is we're going to look at what the picture tells us and see what properties of those items that are shown that we can possibly use to solve what we need. Alright, so I'm going to draw a picture and then we're going to go from there. Here we have this. We have a triangle coming out like that. This is a right triangle because they give us that. This little side here is 6. This side here is 8. And what do we need to do? We have all of this area here dotted. It's a shaded thing. And we need to find what is the area of the shaded region. The shaded region just means the part that has all the dots in it. Alright, so let's take this and just be logical. We also need to know that this guy here is 10. I don't know if we need it or not, but this is what we're told. And this guy here is 11. Alright, so this is a rectangle with a triangle on the inside. And the first thing I'm going to do is mark up what I know about rectangles. This side is congruent to this side, and this side is congruent to this side. So that means that this is 10, and this is 11. Okay, to find the area of the shaded, that's how I'm going to use my notation, it's going to equal, see if this makes sense, the area of the rectangle minus the area of the triangle. So instead of writing that all out in a lot of words, this is my notation. The area of the shaded region, how do I find it? Well, I get the area of the entire rectangle and subtract out that triangle, which is not shaded. And that should give me the thing that I need. Okay, so what I need to do now is look at this part of my formula. Do I know the area of a rectangle? Area of the rectangle is length times width. Do we know those values? Absolutely, they gave them to us. So it's going to be 11 times 10, which comes out to be 110. And now I'm looking at this part of my formula. I need to know the area of the triangle. Well, any triangle is base times height divided by 2. Well, they gave us the base of the triangle and they gave us the height of the triangle. The thing that you got to realize is that they're right here. Here's your base of the triangle. Here's the height of the triangle. So it's going to be 8 times 6 divided by 2. 8 times 6 is 48 divided by 2. So the area of the triangle is 48 divided by 2 is 24. Alright, back to our entire blurb here. The area of the shaded is the rectangle, which is 110, minus the triangle, which is 24. So the area of the shaded region, all we have to do is subtract those guys. Let's see, that'll be 6, bringing it up to 30, 70, so that'll be 86. And what are my units? Did they give me units? Nope, we're going to say inches squared. There we go. So just to cap it off, what did we do? We looked at the picture. They gave us a ton of information. We identified where the shaded region was. We made a statement of how to find the shaded region, and then we just chunked it down and found each of these things. The area of the rectangle first, the area of the triangle second, and then we applied the minus sign between them, and bam, we were done. Let's try another one. Alright, let's try a second problem here. Slide this guy up. Alright, we're going to have another rectangle. And this time we'll say that this guy's 12, this guy's 10. We'll do another right triangle on the inside. And shaded region, all this again. This one's pretty similar. And we're going to need to find the area of the shaded region. So again, just take an eyeball at it. What makes sense to find the area of the shaded region? Same deal. So area of the shaded equals area of the rectangle minus the area of the right triangle. So let's just break them off. Area of the rectangle, that is length times width. They gave us both of those numbers. So it's 12 times 10, which is 120. The area of the triangle, well, any triangle is 1/2 base height or base height over 2. And, oh, I forgot to write that in. I apologize. We do know that this side is 6 and that side is 8. Hey, that's just like the last problem. So the base of our triangle is 6. The height of our triangle is 8 divided by 2. Yep, these are exactly the same numbers here. Alright, so now we go back to that formula we created. Area of the shaded equals area of the rectangle, which is 120, minus the area of the triangle, which is 24. When we subtract those out, 6 will give me 30, so that's going to be 7. That's going to give me 96, and we'll say that we are talking about inches squared. Alright, let's do another one. Next up, this one's gonna look a little bit different. This time our the bulk of the figure is gonna be a triangle actually. And it's a right triangle. We have a rectangle inside of it. Alright, this little piece is not drawn to scale. That little piece is 1 unit. This little piece is 3 units. Our triangle bottom or the base is 10. This is 5. And this is 2. Okay, I have all the information I need. And this is all of our shaded region. Okay, so I am going to mark up what I know about rectangles. This is equal to this, and that is equal to that. So let's take a peek. The area of the shaded this time is going to equal the area of the triangle minusing out the area of that rectangle. It's like someone took it and punched out the rectangle, so that leaves us with everything else. Alright, so area of the triangle, our formula in general for triangles is base times height divided by 2. And I can see our base is 10, so we have 10 times, and our height is this whole side. So let's add up all of the numbers on that side. We have a 1, this here is 5, so that gives us 6, and then plus 3 is 9. So the area of the triangle, 10 times 9 is 90, divided by 2, which gives us 45. Okay, the other part of our equation is we need to find the area of the rectangle. The area formula for a rectangle is length times width. They gave us both of those, which is 5 times 2, so it's 10 units squared. Back to the whole equation. The area of the shaded equals the area of the triangle, which we know is 45, minus the area of the rectangle, which is 10. So it's going to be 35, we'll say it's feet squared. There you go. I'm going to do one more problem with areas involving rectangles and triangles. If you're brave, why don't you give it a, we'll copy the problem first down, hit pause, and then give it a whirl on your own and see how it goes. Alright, last problem for this section. We're going to draw a rectangle. And we are going to have a triangle, and the rectangle is going to be sitting in front of it. That side's 2, that side's 5. This side here is 6. And this side here is 3. Again, not drawn to scale by any stretch, but it gives you a good sense of what's happening. And this is our shaded region, all of this. Alright, so if you have that copied down, hit pause and see if you can solve it out for yourself. When I analyze the situation, I realize that the area of the shaded region is going to be the area of the triangle minus the area of the rectangle. So, let's chunk it out. Area of the triangle, our formula is base times height divided by 2. Well, triangle is it's partially filled in. This is our base, which is actually 6 plus 2, so that's going to be 8. Our height is actually this whole side, which will be 3 plus 5, which will also be 8. So we get 64 over 2, which becomes 32. For the area of the rectangle, they gave us all the information we need. It's just length times width. Our length, we could say, is 5. Our width is 2. When we multiply them, we'll get 10 units squared. So back to our original equation that we wrote, this one here. For the area of the shaded, it's going to equal area of the triangle, which is 32, minus the area of the rectangle, which is 10, So it'll be 22 centimeters squared. There we go. Alright, if you need any help clarifying, anything like that, just come find me.